Hi class. So please turn to section 281 and find a blank page in section 281 and let's do the warm-up for today. I want to remind you that since you are watching this on your own, you can pause at any point, rewind at any point if you need to hear something said again, as well as fast forward if you understand what's going on. So let's get started. Our warm-up today says given y equals 1/2 x plus 9, write the equation of a line that is parallel to the equation that goes through the point -12, 4. So in order to write an equation of a line, we need two things. We need a point and we need a line, and a slope. So our point is given to us right here, and since the lines are parallel, our slope will be the same. So we start in point slope form. Y minus our y coordinate equals our slope times the quantity x minus our x coordinate, so plus 12. Distribute the 1/2. We get y minus 4 equals 1/2 x plus 6. Add the 4 over, we get y equals 1/2 x plus 10. Nice review since our test is coming up next week. Here is our homework in case you'd like to check any of your answers. Homework last night was to do problems 1 through 5. And today our objective, by the end of class, you should be able to use slope, point slope form, and distance formula to calculate the area of triangles and rectangles. So yesterday we did perimeter, and today we're going to go ahead and do area. So example 3, we're actually going to skip and come back to. I want us to do example 4 first. So in example 4, we're given that ABCD is a rectangle and has vertices at -3, 4, -3, -4. B is at -1, 2, C is at 2, 1, and D is at 0, -5. And we need to calculate the area of the rectangle. So our formula for the area of a rectangle is base times height There we go. Area of a rectangle is base times height. So we have area equals the length of the base times the length of the height. So what we need to do is we need to find the length of the base and we need to find the length of the height so that we can multiply them together to get our area. So since we're given coordinates and we're given a grid, we can go ahead and use distance formula. I'm going to use Pythagorean theorem since we're given the grid, because Pythagorean theorem is just a little bit easier when you're given a grid. So to find the measure of line segment AD, I'm going to call that our base. We have a right triangle with side length 1, a right triangle with side length 3, so 1 squared plus 3 squared equals our base squared. So we get our base squared equals 1 plus 9, base squared equals 10, so the length of our base is the square root of 10. For our height, I'm going to make line segment AB be our height. So we make a right triangle, has a leg of 2 and a leg of 1, 2, 3, 4, 5, 6. So we have 2 squared plus 6 squared gives us our height squared. So we get our height squared equals 4 plus 36. So our height squared equals 40. So our height is the square root of 40. So now to find our area, like it says up top, we know that area equals base times height. So we have square root of 10 times square root of 40, which is the square root of 400, which is 20 units squared. Nice and easy. Now to find an area of a triangle, let's take a look at example 3. Our formula for the area of a triangle is base times height divided by 2. Problem with this formula is that in order to find my height, I'm going to have to find the length of the perpendicular segment, just like we did in section 572, finding the length of the distance between a point and a line is always the length of the perpendicular segment. We would have to do the same thing here to find the length of the height. However, there is a much easier way. This way is called encapsulating. So what we're going to do if we're using the encapsulating method is the first thing that I'm going to do is I'm going to encapsulate the triangle in a rectangle. Essentially, what I did for Pythagorean theorem in our last example, I'm going to do here on all 3 sides to form a rectangle. So we have a rectangle that completely encapsulates our triangle. Now, why do we do that? Because finding the area of a rectangle is easy, and calculating distances that are horizontal and vertical are easy to do. No distance formula required because we can just count. So then what we're going to do is we're going to encapsulate our triangle in a rectangle, and then we are going to find the area of our rectangle. Then we're going to find the area of our triangle, there are multiple, there are 3, and then we're going to subtract. Area of the rectangle minus the area of those right triangles will give us the area of our initial triangle. So let's go ahead and do that. So the area of my rectangle, again, formula is base times height. So if we look here, our base is 1, 2, 3, 4. And our height is 1, 2, 3, 4, 5, 6. So our area is 4 times 6, or 24 square units. Now let's find the area of each triangle. So I'm just going to number these: triangle 1, triangle 2, triangle 3. So the area of the right triangles is 1/2 base times height. And since they're all right triangles and each base and height is vertical and horizontal, again, it's as easy as counting. So the area of triangle 1 is going to be our base, which is 4, times our height, which is 2, divided by 2. So 2 times 4 divided by 2, which is 4 square units. The area of our second triangle is 1, 2, 3, 4 units high, 1, 2, 3 units for the base. So base times height divided by 2, or 4 times 3 divided by 2 gives us 6 square units. And then our third triangle has a base of 1 and a height of 6. 1, 2, 3, 4, 5, 6. So base times height divided by 2 gives us 6 times 1 divided by 2, which is 3 square units. So our total area of our triangles is 4 plus 6 plus 3, or 13 square units. So I have my area of my rectangle is 24 square units. That's the whole thing. Area of my triangles, my 3 right triangles, so the part that we don't need, is 13 square units. So my area of that original triangle is 24 square units minus 13 square units, which gives us 11 square units. All right, so that's how we find the area of a triangle. You guys have the rest of the period to work on the 582 problem-based task. Yesterday we found the perimeter. Today I want us to find the area of the fenced field. And keep in mind that each unit on the map represents 10 feet. When you are finished with that, you guys have the rest of the period to start on your homework, which, to remind you one more time, is 581 practice numbers 6 through 10. And it is assignment number 6. So I will see you all tomorrow. I'm sorry, Monday. Have a great weekend.